This episode of Fluid Power Forum is sponsored by eShipping, a distribution change management company offering transportation, warehousing, and technology services. Learn more at eshipping.biz. Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, as always, we ask that you please follow us on Twitter. You can find us there at the NFPA. And while you're there, share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is, in fact, one of the ways that we source topics for the show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on all the popular podcatching services, Apple Podcasts, Spotify. Wherever you find us, subscribe and then give us a quick rating. That really does help spread the word and help more of our friends in the industry learn about the show and join in on these important conversations. On today's show, our guest is Antigone Sharris. Antigone is chair and full-time faculty in the Engineering Technology Department of Triton College in River Grove, Illinois. Triton College is an NFPA fast-track hub for our workforce development program, which is designed to create stronger connections between technical colleges, industry partners, and local teachers by engaging multiple education levels in the community. And today we invited Antigone into our forum to learn more about Triton's status as a fast-track hub and about the students and educators that are helping to shape the future of the fluid power industry. So Antigone, welcome to Fluid Power Forum.
Thank you for having me. Happy to be here this morning with you.
We're glad to have you on the show. Every once in a while on our podcast, we talk about the future, about education and the students that are going to shape the future of our industry. And today is going to be one of those episodes. I'm looking forward to that discussion. Tell me, before we get into that though, tell our listeners a little bit more about yourself. How did you find yourself in your position at Triton College?
For me, it was a long journey. My core is manufacturing. That's where I came from, and that's where I still am, of course. Mm-hmm. When I was in high school, I went to Lane Technical High School back when it was Lane Technical High School, and they had shop classes. So by my senior year, I worked at a manufacturer in their industrial cooperative ed program.
Okay.
At the high school. That's gone too, along with all their shops.
Right.
That's another conversation. The result was working for Janet Kaiser at Century Metal at the time when it was in the city. Told me, yeah, I can do this. Number one. Two, I can do it as, in my case, as a female in
Right.
a male-dominated profession.
Right.
And that's it. This is what I want to do. So those were some of the experiences I had. And then I knew I wanted to also teach because I enjoyed being around people and helping others. So I focused on what type of bachelor's degree would dovetail both of my interests. And I have my associates as well. So I ended up getting an associate's in engineering technology, a bachelor's in vocational ed. And now I also have a master's from IIT and in the operations and management side. So logistics and operations is my specialty. My bachelor's was at U of I. Champaign.
Uh-huh.
And then my field experience was with LK Manufacturing. And then I started teaching part-time over at Triton. I did do my associates there as well. So I understand the role of education in a person's professional development.
Right.
More than I still think many do not, but that's another issue that we have. And the outcome was that the guys retired. They're like, you should apply. I said, I don't think so. I'm not politically correct to be in education. But I applied anyways. So here I am.
That's great.
20 some odd years later, still doing, trying to do what's right by the students and what's right by industry to find that happy marriage of the yin-yang relationship of industry and academia.
Yeah, that's a fascinating backstory there, Antigone, and I guess I want to start first with, tell us that initial interest that you had in industrial arts and manufacturing. Like, where do you think that came from? Like, what really drew you to that?
In my house, we were immigrant family.
Mm-hmm.
My mother and I came from Yugoslavia, the former Yugoslavia now.
Mm-hmm.
And both of my parents were in World War II. My mom experienced it as a teenager in Yugoslavia. My father was in the army here from the United States.
Yeah.
And the family dynamic was, if you couldn't afford it, it doesn't matter. It's the point is, if it breaks it, you fix it. You do what you can without having to buy stuff.
Yeah.
So there was a very World War II life that I grew up in, and I think that was a big piece in just strong work ethic, repair, recycle, repurpose a lot, by the way.
Yeah. Right.
Came from there, and so I was always helping my dad fix things before he passed away.
Yeah.
So then when I went into high school and got into shop, everyone was back then at Lane, everyone was required to take 2 years of shop.
Right.
So in my case, I also did commercial art because I love to draw. So combining the two talents, I did competitions, drafting competition and the commercial art competition, won both. So I had that ability to keep engaging in those areas.
Mm-hmm.
I wasn't athletic. Today, most things in high schools are just athletic, so the kids don't have a chance to show their stuff outside of athletics.
Right.
It's pretty sad. It's very annoying. That's why I support IDA drafting competition at this level, the Fluid Power Challenge. I supported it before I ever became a hub. I support the FIRST Robotics. I do all that because I know I'm a product of those things.
That's
I
great.
wasn't the athlete. I was a mental athlete, not a physical one. And the high schools and the grade schools were all guilty, and colleges are all guilty of pretty much focusing on athletics,
Right.
and not on us.
Yeah. Well,
So academic athletics. So the outcome was I was fostered into just enjoying it.
yeah. Well, that's great. As you said, it's been a painful couple of decades, as a lot of those industrial arts programs have vanished, if you will. And
Oh, yeah.
Triton is doing a great job, and NFPA is playing a small part in helping bring some of that back as we go forward. I'm also curious about your background as you went through both in the industry and then in the college. How much fluid power were you exposed to, if any?
Very little.
Yeah.
None, I would have to argue. When I came into the college, U of I was a different ballgame. Still theoretical. It was very hard on me.
Yeah.
So I knew that I wasn't going to do the engineering route. So I knew that I was definitely wanted a more practical aspect. And that was the reverse transfer. I started at U of I, then reversed out into the community college system to get my core major, and that was in engineering technology. My focus at the time ended up being with the CAD and design.
Mm-hmm.
And working at LK, I learned all about the hydraulic systems that they had out in the shop, but I
Sure.
learned it in practice, not as
Right.
not as a subject. So it was everything I ended up picking up physically,
Yeah.
not in an academic setting.
It's
So
it's-
when the roles were reversed and I'm standing there in the classroom and they had trainers there, I had a little bit of an issue with the trainers. So I had the students take them apart.
Yeah.
And we started building from scratch,
Learn
because
how
I'm
they
like,
work.
you know what, they're not going to learn much
Right.
playing with the little buttons. I think we're going to flip the table. And I know nowadays that's actually what they're trying to get schools to do, which
Yeah.
is move to hands-on in the classroom and the theory, do it as homework. So it's kind of
Absolutely.
interesting that I took the engineering model of, I'll call it that I had at Lane, which is learning by doing, which was based on the German model. I know
Right.
it's historical, but it's tried and true. It's a very good model.
Very much. Yeah.
You learn by doing, not by just talking about it in a book.
And that's a big part of the fast track curriculum, if you will, and we'll get there in a moment. But tell us a little bit more about Triton College as an institution. What does it have focus areas that it's focused on? How would you describe it?
Triton College is, I think, everything for everyone. It's a wonderful institution that has, even when I was a student, my cousin went there. So that's how I got introduced to it as a kid. I actually went to Triton for my drafting competition. So that's how I got introduced to them. So they have a history of supporting this beyond, but pre-me. It had nothing to do with me. I just happened to join the team and say, yeah, I still want to do this. So it's been an institution that has always had a strong foundation, I think, from what I've seen in the technical area.
Sure.
Their logo, the seal, the Triton College seal, has all the elements of engineering in its seal. It's beautiful. And the focus, the campus, you can go from business to, we have a awesome culinary program. We've got a great automotive, visual communications at Triton, the visual arts area with the amount of content knowledge you learn in the Adobe. There's a lot of areas of the campus that can serve any business on so many levels. It's amazing. And the students want to be there, and that's what keeps me there.
Sure.
As an instructor, I've been to other campuses in different capacities, just visiting and also partnering on different activities. And you see the students want to learn and they want to be there.
Yeah.
It's a wonderful, I think it's a great place to be, but I'm biased. I'm there.
Well, it is. And I've been there myself. It is a great place to be. Do you know off the top of your head how large the student body is there? How many students are we talking about?
I think, but COVID has messed everybody up. So in fact, I was looking, I think it's maybe like head count 1,400 students.
Okay.
Somewhere around there, mostly part-time. I mean, right now, the environment as far as full-time versus part-time, even my full-time students are all working. It's an interesting scenario the last couple of years. But historically, a lot of I would usually have 30% of the students working full-time, and then the middle group was like half and half, somewhere in there with work and school. And then I'd have another 30% that was full-time student with not working. So it's an interesting shift this last couple of years, especially.
And are the students mostly people right out of high school, or are they older people?
No, definitely a mixed bag.
Yeah.
When I look at the demographics of just the spring classes, for example, we're pulling in as a campus for the spring semester. We've got, I think, the good enrollment. But I know that most of my students specifically are in their 20s.
Yeah.
So I would say mid-range between right out of high school, and some of them right out of college in the sense that they transferred out of university because they weren't satisfied there, like when I was them. And then on the other end, we've got the adult learners. So I would say about 25 years old is the average age.
Well, it's a sizable program, it sounds like. And, I want to learn more about, and I want our listeners to learn more about what a fast track hub actually is. But maybe we'll start with, how did you first get connected to NFPA? How did that come about?
12 years ago, roughly.
Yeah.
So long, of all things, it was Deltrol, which is a company that's in our district, is one of the NFPA members. Their president at the time was also president of NFPA, and one of their employees was one of my students. There you go for a convoluted beginning.
Well, I know the name of the president that you're trying to remember. That's Bill Parks, more than likely.
Yes, Bill Parks, yes. Yeah. And then they wanted some help with, it was some type of NFPA. Can you do this? And we said, oh yeah, sure, whatever. We're happy to help out. Right. And then one thing led to another, and here we are.
So what was that initial ask? Was it, it
was an ask for a campus event.
Okay.
They wanted us to just do an outreach for NFPA. So we did, and then we did another one and another one. We had Leiden High School come to us, and we did like an NFPA day. And Bob from Deltrol and I were working together to help the group of what were they? Project Lead the Way students came by.
Yeah, well,
and we worked with them, and then we just kept working on different activities, weekend stuff, and then there were some in classroom. I did an event with a bunch of first graders, and I had them put together little fluid power systems.
Right.
And I loved it when the one little girl came up to me and said, I want to be just like you. And I said, yes, that's it. That's what it's about.
Victory.
And if I can get them at first grade to want to be in engineering, heck yes, that's the best.
Yeah, you're describing a time, in NFPA's own development where, as you're describing, we were interested in doing what I would call outreach. We wanted to connect younger and younger people into education and career pathways for fluid power, and we desperately needed to partner with local schools in order to make that happen. And we were very happy to start that initial partnership, as you described, through Deltrol and start working with you. A lot of that got reorganized or more organized over the years into this thing that we now call Fast Track to Fluid Power, which contains a lot of different kind of sub-programs in it. But I'm curious from Triton's perspective and from your perspective, what was that process like? A lot of it began with working together to ensure curriculum is being delivered appropriately, right? So
Correct. Yeah, we went through a whole conversation. We're doing a checklist against the NFPA guidelines of what they would expect in a fluid power curriculum.
Right.
And ours, when it came to curriculum, ours is the mechatronics based. So we had electricity as a separate class. We had PLCs as a separate class.
Mm-hmm.
And the fluid power specific, we offered one course. I want to expand on that to ultimately offer a second. And I think getting into robotic welding, which is the next step at our college, will be the catalyst to allow for that, because we need enough growth in the curriculum to accommodate the headcount required per class.
Right.
Historically, academia, I came from industry, so I did scheduling, coordination, stuff like that. And then part of in order to offer a holistic curriculum, you can't just put everything on the table and then hope people enroll. No, it doesn't work like that.
Mm-hmm.
You have to have a plan. So a curriculum plan is important for the student side, and we needed to make sure, of course, we also had headcount because we have to accommodate, obviously, dealing with costs. So I was able to get, we offered fluid power maybe every other semester back in the day,
yeah.
And it wasn't really running that often because the headcount wasn't there. Now we're able to consistently run it every semester and it fills. And now we're getting to the point of running a morning and a night section. COVID kind of screwed everything up, but that's another conversation. So we're getting back into the swing of things. So is it still just the one fluid power course in the mechatronics program, or is fluid power more developed in other areas as well? We've got it developed in two programs, but mechanical design and mechatronics,
mm-hmm.
because it's when working with companies, fluid power is ubiquitous. It's basically in everybody's business.
Right.
And from maintenance through design, solutions in design, how you want to close things without slamming doors, things. There's mechanical and there's fluid. Fluid has its obvious advantages over mechanical in the sense that you can do a closed system and you don't have to worry about repairs as often.
Right.
So there's a definite plus side of going with a fluid-based mechanism versus gears that just wear out, and there's more maintenance we're talking about product life cycle. So anyways, getting off of that. The outcome is we got the course in both areas. Now we can offer it every semester. The goal is then to offer a part 2, because right now we basically focus on pneumatics, and I want to get into hydraulics.
Right. Well,
hydraulics for us will be mostly water for obvious reasons. But the point is that's the next step. And I think once we get the robotic welding going, then we can then add that.
Well, I'm curious about, now that you have the courses, the enrollment is strong, they fill every semester, I guess, right?
Yes.
What advantages do you see the students getting from having that kind of curriculum there? What does it fit better in their overall portfolio of expertises that they need to have, or what other benefits do you see?
Yes, they've got, as far as the curriculum itself, they're able to be multifaceted and be, as I call it, the multi-tool that companies are looking to hire. I've yet to find a company that says, I really only want them to know how to do one thing.
Right.
That doesn't exist in any business, not just manufacturing, but for us especially, we're ultimately we're looking for multi-tools.
Yeah.
I know that. I was one of them, and I see the advantage on the student side to be that multifaceted individual that can bring a couple of things to the table, not just CAD or not just welding, not just get it, not just peel. It's really they're looking for that whole person.
Right.
Some companies, of course, are looking for 20 years experience in a 20-year-old, but that's another conversation.
Well, I mean,
I can't fix that piece, but I can fix the part that most companies are after, which is give me someone who's well-rounded.
right. Yeah, I've
And
always said,
well-rounded for us doesn't mean they took English and math and science. And no, they don't. They mean like well-rounded in different areas of engineering.
well, yeah. I mean, within the context of mechatronics, fluid power is a tool that is going to be able to solve some of your problems, not all of your problems, but there are problems that if you don't have fluid power, you won't be able to solve. And I think that's really kind of the core issue, right? So,
exactly. Well, compactness, when we think about the design process, why would I go fluid power over a gearbox? I can create X amount of power in the small amount of space. If we go to hydraulic, depending on the liquid choice, then you have all these other opportunities. And there are so many industries in manufacturing, Twinkies, food products. I always talk about yummy. I love Twinkies. Sorry. They're
fine.
My preferred.
We can manufacture anything. Only fluid power can deliver Twinkies to your door. So
That's right. That's what I always talk about. Who do you think makes that food? And by the way, how many people you want touching your food before you touch it?
Right.
Nobody. So there's a lot of automation. So anything that's automated requires some element of pneumatics and hydraulics in order to speed things up, because the gears don't go fast enough.
Right.
And if they do, they usually get their teeth knocked off. There's a whole set of issues associated with that mechanical approach that the pneumatics just solves.
Right.
And it's just easier. Plus, with pneumatics, you have a cleanliness situation. You don't have to worry about that around food.
Well, Antigone, we've reached the point in our show where we need to take just a quick break here and provide our listeners with an update on some other fluid power industry opportunities. NFPA's latest edition of the U.S. Fluid Power Industry Brief is now available for download from the NFPA website. The brief is a convenient compilation of industry facts and data, which can be used to understand and promote the growing fluid power industry. You can use the brief to encourage a student to pursue a career in fluid power, to educate your network on the value of your business and industry, or just better explain to a family member what it is you do and why you love it. To view and download the brief, head to nfpa.com and look for the U.S. Fluid Power Industry Brief under the Industry and Stats tab. Go there now, download that file, and share it with anyone you think would benefit from our content. Working together, we can promote and grow the fluid power industry. Okay, we're back from our break, and I'm speaking with Antigone Sharris of Triton College, and we were just talking about the importance of having fluid power in a mechatronics program there. I'm curious, Antigone, can you be more specific about some of the resources that Triton students get access to as they go through this program? What's that? You talked earlier about hands-on learning. What are some of the hands-on things that they're doing in the program?
They get access to actual hydraulic and pneumatic systems, mostly pneumatics, but the cylinders we use can go either way.
Mm-hmm.
They're hydraulic or pneumatic. What's really neat is BIMBA gave us a bunch of their product that when they were doing their inventory reviews and they didn't need any product. So they donated to us a variety of cylinders that we can now use. And that gave more students more access to more stuff. So some students were like, well, I can't make this system because I don't have this kind of cylinder. Yes, you do. Double end rod, for example.
Right.
We didn't have those before BIMBA gave them to us. So we had that was wonderful. And then NFPA also gave us funding so that we could buy switches, and we've got all types of the tubing and all the things that go into just building a pneumatic system. And they can also be used for hydraulics. And the beauty of it is our students are being able to build things from scratch so that they can make their ideas reality. They're learning where a pneumatic system should go and where it is most functionally useful in a system.
Mm-hmm.
And that is something we can't teach out of a book. We can talk about it, but they're literally learning by doing it. And we wouldn't be able to do that without the help of NFPA and its members. And also they come in and talk to the students as well.
Right.
We had Deltrol come in and show the students where's the reality of what they're talking about, and show them how it's used in medical and bed manufacturing for hydraulically controlled beds.
Yeah, as one example. Yeah, it's one of the best parts of the program. Not only are you actually building systems out of actual product, but as you said, through those industry liaisons, you're learning how it's applied in the real world and what kind of career opportunities would probably be available to you once you understand how the technology works.
And on that side, we had one of our students actually be in that internship that they offer. Deltrol had needed somebody, and it was nice that our students then were able to get that. And of course, the benefits they have for having the scholarship access to allow them to not have to worry about that particular aspect of their academic life. They can then pursue this topic further and hopefully become a future employee of an NFPA business. That's our goal.
Absolutely. So, I know that one of the, so we've talked a lot about what happens at Triton, if you will, in terms of the students that go through this program, this Fast Track to Fluid Power program. But Fast Track is broader than that because it contains outreach activities to local high schools and local middle schools to try to develop a pipeline, if you will, of new students into the program each year. Can you talk a little bit about what Triton does with local high schools as part of that effort?
Sure. What happens, it was pre-Fast Track. We would host different activities by us, and we would go to their schools as well. And it's also the grade schools. I've always promoted that we have to work with the grade schools because the kids get it in their head of what they should or shouldn't do in grade school before they get to high school. And in high school, that's where the fluid power challenges with the grade schools, and that's mission critical. We just finished a fluid power competition with one of our area grade schools in partnership with and Ridgewood High School. So the grade school ended up, we had maybe about 50 kids in competition. It was a wonderful event. And our ultimate goal is to have the high schools be like I'll call it the regional competition site, so to speak, for the grade schools that serve that district. And then those high schools, the top kids from that competition will come over to Triton. So that way we have like a buildup of a competition. Right. So that the kids, it didn't happen. Again, this was pre-COVID, didn't happen. But now we're getting back to that. Yeah. Trying to get our other high school Leiden to do the same thing. We're hoping that next year we can do that using Ridgewood as the example so that we can build up the momentum to go back to that plan. Right. And it wouldn't be possible. Let's put it that way. I can talk about it till I'm blue in the face. I've been involved in FIRST Robotics, to give you an example, for 16 years now. Yeah. And there is no way I could do anything without the fact that first is first, just like with this, the opportunity to have a structured environment to be able to do this. Because me just going to a school and saying, hey, why don't you do this? Not going to happen. Right. So with this plan, though, it makes it so much easier. Yeah. I mean, what you're describing is what we call the Fluid Power Action Challenge, which is the program that goes into, as you said, middle schools, and I guess it sounds like grade schools as well, with an engineering fluid power based challenge for all of those students to perform. They actually build fluid power activated mechanisms out of very simple materials, paper gussets and wood structures and syringes with water in them, which serve as the hydraulics, if you will. And then they compete against each other in timed competitions. And it's really, we use Triton as kind of the headquarters, if you will, or the base to kind of
go out into the community and engage students in those kinds of activities with the hope that it will get them excited about fluid power as a technology.
I'm hoping to scale it up where the kids, once they get out of their grade schools, I'm not trying to get to a point where I could offer a summer program.
Right.
We incorporate a little bit of the fluid power in our summer camps that we do. Have gadget and girls adventuring design, engineering, and tech. And we actually want to do a straight up fluid power camp.
Great.
In the future. We're working on that. And there the kids that have participated in these other programs or been at a school where they didn't have that opportunity can do it with real equipment, not the syringes.
Right.
And that's the goal of mine. And then hopefully have a high school level version of the Fluid Power Action Challenge where it would be the high schools doing it. Now, what's nice is First Robotics has, through NFPA, if I understand correctly, that opportunity is there because they're getting pneumatics as part of their opportunity to use on the robots.
Right.
So for me, it's a perfect scale up where I dovetail both activities. In our district, only one high school, sadly, is doing the First Robotics. Their competition is this upcoming weekend here in Chicagoland, and that is Proviso. So
Right.
I've got a team in Proviso I've been working with, but I would like to get Leiden. Ridgewood had a team. Hopefully they'll have one in the future. But it would be nice to get the area high schools then to get into that. Then we can basically double down on how they're using fluid power. And then I think by the time they're 18, they'll be intern ready for these businesses and then move forward into our curriculum.
Right.
And then become professionals.
So I'm curious, all of these different outreach activities that you're describing as a way of trying to generate interest, what kind of feedback, if any, are you getting from either students or even teachers and parents that you encounter in those programs? Or is it working, or are people getting excited to go on and study at Triton and move into a career?
Out of all of them, the Action Challenge is newer. You know, the Fluid Power Action Challenge. So that one I haven't been able to track the kids in because I also don't record their enrollment in that activity.
Right.
I can only ask the grade school teacher in question. I know it's like they say middle school, but in our grade schools, it's the whole thing.
Right.
They don't have a separate middle school, so it's grade school.
Okay.
So it's nice that the younger grades get to see the kids, what they're doing. That's actually good.
Right.
But those kids, they're excited. They like the thing. So their feedback is they enjoy doing it. Now, my part is to try to give them something else to do to keep them interested. That's the next step.
Yeah.
So that's where the summer camps come in. And some of those same students will become summer camp participants, and they enjoy that. Of the whole family, after 16 years of being involved between first, 12 years of gadget and whatnot, and with all these activities, the result is maybe about 10% become ours, which may or may not have occurred other ways, but that's the 10% I'm looking at.
Exactly.
Mind you. What I've learned, though, is that I've got my enrollment at the college throughout this entire time, though, has always been going up. And when I ask those students, how did you find out about this curriculum? They'll talk about something they did in grade school or something they did in high school or saw their friends doing.
Right.
That's the other catch.
Right.
But I can't capture that. So I have a feeling, in my opinion, I can't do it empirically because I have to do the data analysis. And there's no way of me tracking an entire school and their outcomes,
right,
at least at my level. And what I've learned is we've got people coming in because of they went into Project Lead the Way curriculum in the high school, or they chose to take an engineering class in high school because of these experiences they had. And or their friends were doing it. They said, hey, I've not seen that before. I like that. I'm going to do this myself. So their friend may have been involved in the program and just not, eventually didn't get interested in it, but they did.
Right.
So I would probably argue that I think about 20% of my enrollment is a product of these engagements.
Well, that's huge. Yeah. I mean, it really
Which is huge.
It is. Yeah.
During COVID, to give you an example, other schools were experiencing a decline in enrollment. In our case, we were not. Our curriculum fall of 2021 actually is where it was spring of 2020.
Right.
And that is higher than where it was.
Yeah. Antigone, I was going to ask, you mentioned a couple times internships and working with local industry, Deltrol and others. Do you have any success stories that you can describe about students who have graduated from the program and gone on to successful careers in our industry?
The intern from Hydroforce,
Mm-hmm.
he's with Lockheed Martin in Texas now. So, and that is, they use pneumatics and hydraulics in their systems. So a lot of our students have moved into professions that are using hydraulics and pneumatics as part of the job.
Right.
We've got 3 different heads of engineering. One of them became head of an engineering department that made ventilators. So our students are getting into from the time frame that I've worked with NFPA, we've worked with NFPA as a school. We have students who are in various levels of management, as well as production, product design, R&D, and they're all these businesses are using fluid power systems. At Deltrol specifically, our guy then moved on to, now I think he's full-time making CNCs. So it's really neat stuff.
Yeah. Well, that's a great testimony to how, as you said earlier, how ubiquitous the fluid power technology is. It's used in so many different places that people with these skill sets can get a job in a lot of different industries because a lot of industries depend on this.
Yes. It's to me, it's equivalent to nuts, bolts, and washers.
Right.
When it's like it's that mission critical. The fluid power products are very valuable in so many businesses.
Right. Well, this has been a great overview of all the different opportunities that are available through this fast track program at Triton College. The outreach to the local schools, and then the focused curriculum at the technical college itself, and then all the career opportunities. So I really appreciate that overview. What do you think is next? What's the future at Triton College for this program? Do you see continued growth? How would you describe the future?
Going forward, we're going to be adding robotic welding. Welding was the latest thing we added to the family, so that my ultimate goal, approximately 15 years ago now at this point, was to add robotic welding. And because that is the fusing method of how we put things together with the welding is important, and robotic welding is getting into automation, cobots and all that. We already have the robotics. Now with the welding component, that will step up the curriculum and merge the 2 areas again, because that's what was different. We had mechatronics, which had robotics, and then we had mechanical design, which included welding. Now the 2 are going to be capstone together with robotic welding, and with that comes all these pneumatic fixturing. That's why I'm saying I'm going to be able to then bring up the level to hydraulics, because parts are heavier than a pneumatic system might be able to push it along. So now you have the hydraulic component. So that's going to build up the opportunity for the hydraulic curriculum. And ultimately, I want to see students be able to build their own robots, literally,
right,
from nothing, because we have all the coursework that allows them to do that. By that point, we'll have everything.
Well, that sounds very exciting, and again, even more valuable skill sets for the industry to capitalize upon.
That's the goal. Thank you.
All right. Well, thank you, Antigone, and that is going to wrap things up for this episode of Fluid Power Forum. My thanks to Antigone Sharris, who has been my guest on this episode. If you'd like to connect with her, learn even more about what's going on at Triton College, you can do that by contacting her via email. And we're going to put a link to her email address in the show notes for this episode. Remember, if you like our podcast, please follow us on Twitter. You can find us there at the NFPA. And make sure to keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. Also, to see the latest fluid power technology and learn from industry experts, make your plans now to attend IFPE, the International Fluid Power Exposition. Our next show will be March of 2023 in Las Vegas, Nevada. For more information, visit ifpe.com. I'm Eric Lenke of the National Fluid Power Association, reminding you to join us next time in the forum.